Welcome back, everybody. And today we're looking at the second of a three-part series of videos on the natural recursive form of a sequence. So once again, we're having a series of videos on sequences. But this is recursive form, and in the last video we did look at very closely what is the recursive notation for this one. And let me just write it out for you above here. It was a sub 1 was equal to negative 1, and a sub n was equal to a sub n minus 1 plus, and we discovered that if you take 2n minus 3 and add it in there, you'll be able to create the rest of the sequence based on the previous term. And the one thing I didn't like about it was that it had this little n in there. So our job today is to figure out how we can rewrite this sequence, which is explicitly defined here, in a purely recursive manner. So I'd like to show you how to do that today. So let's give it a shot. First thing we're going to do is we're going to write down some things about a sub n. First of all, let's get some terms written in here again. This is what we had from the previous video. And I'll just write 4 of them in there. So it should have been negative 1, 0, 3, and then 8. Now, one of the things we're noticing in our formula right over here is that we have an n. And we want to get rid of that n. However, at this time, that n is the number that is here. And so the first term that we're going to be dealing with is the number 2, because the number 2 is the second term. It's located right here. However, the previous term is a sub n minus 1. And so we would like to somehow get that a sub n minus 1 involved in the n. And a sub n minus 1 is located right here. And the question is, how do we take that n minus a sub n minus 1 and turn it into this number 2? And if we can somehow turn it into that number 2, we can simply replace it right here, because that was supposed to be number 2, replace it in there, and we should have our recursive definition purely written with no n's in it. So how do we do that? Well, let's take a look. We are currently at this location. We want to have this one, and we want that one to actually create the number 2. So I'm going to do a couple of things. The first thing I'm going to do is I'm going to reorganize my sequence. I'm going to rewrite this sequence instead of a sub n. I'm going to write it as a sub n minus 1. And let me show you why I want to do that. A sub n minus 1 is saying I'm taking the same sequence of numbers, but I'm kind of putting them off a bit. So it's n minus 1 squared minus 2 times n minus 1. And notice what happens as we work this out. It's n squared minus 2n plus 1 minus 2n plus 2. And finally, n squared minus 4n plus 3. And that is our a sub n minus 1, which is, of course, a slight difference from our current explicit definition, a sub n. Now let me rewrite a few of these terms, because these terms are going to look a little bit different than our current a sub n. So a sub n minus 1, let's start with a sub 1. Plug a 1 in here, I'm going to get 1 minus 4 plus 3, which is 0. A sub 2, plug a 2 in there, that's going to be 4 minus 8 plus 3 is going to be negative 1. A sub 3 is going to be 9 minus 12 plus 3, which is 0. A sub 4, and I hope you start seeing this soon here, it's going to be 16 minus 16 plus 3, or 3. And finally, a sub 5 is going to be 25 minus 20 plus 3, or 8. And look at that. Now you notice there are the 4 first values of a sub n. But notice how we were successful in matching up the negative 1 with the 2 right over here. So our first step, obviously, is to try to get the previous term's answer value to match up with the current term's index value, if that makes sense. And the way to do that is to substitute n minus 1 in to the original function or the original sequence and create a new sequence right here, n squared minus 4n plus 3. So mission accomplished. We've got our first part. Let me erase just this information below, because those were just the plug and chug values. And now we're going to try to figure out how to turn that negative 1 into a 2. And that, of course, you learned in Algebra 2, the way that you turn a function around and turn the y's into x's is to take the inverse. So we're going to take the inverse of this. It's not that hard to do. We're just going to solve for n. So it's going to be n squared minus 4n is equal to a sub n minus 1 minus 3. course, if we're going to solve for n, we're going to have to complete the square, which is pretty much standard fare in algebra. So that's going to give us a sub n minus 1 plus 1 is equal to n minus 2 quantity squared. Take the square root of both sides, we get n minus 2 is equal to the square root of a sub n minus 1 plus 1. And I want to point out at this point we should have a plus minus in the front here, but we're going to notice that in this particular problem with sequences, we can omit that minus symbol, and we'll show that in the solution in just a minute. So we're just going to take the positive radical in this case, and we're going to get n is equal to 2 plus the square root of a sub n minus 1 plus 1. Wow, what did we just find? We just like undid a sequence somehow. We undid it. So let's go back to the top, and we saw this value right here is n, and n is the guy we wanted to replace. So let's try this. We know that a sub n is equal to a sub n minus 1 plus 2n minus 3, and I believe I can just plug this guy right there, and let's see what we come up with. A sub n is equal to a sub n minus 1 plus 2 times the quantity 2 plus the square root of a sub n minus 1 plus 1 minus 3, or a sub n is equal to a sub n minus 1 plus 4 plus 2 times the square root of a sub n minus 1 plus 1, and then that's minus 3. Notice that this 4 and this 3 will combine, and our final solution here, a sub n is equal to a sub n minus 1 plus 2 times the square root of a sub n minus 1 plus 1 plus 1. Notice now that we have no n values. We have only a sub n minus 1s. In other words, we have a pure recursive notation. So just for fun, let's go ahead and start plugging some numbers into there. A sub 2 is going to equal a sub 1, which from the top of this slide was negative 1. Remember, that's the first term in the sequence of this was negative 1. That's we're talking about our original sequence. So let's move down here again and work that out. It's going to be negative 1 plus 2 square root negative 1 plus 1 plus 1. Or negative 1, this part drops out, plus 1, and we get 0. So that makes sense for the second term. Let's go to the third term. The third term should be the second term, 0 plus 2 square root of the second term, 0 plus 1, plus 1. Or in this case, 2 plus 1, and that comes out to 3. Now, you can go ahead and do more of these if you'd like, but you can see that we clearly have found a representation of a purely recursive, or what we call the natural recursive form of this quadratic sequence. Now, the neat part about this is that this is going to work with any function a sub n that is functional and has an inverse. So whatever this function is, doesn't matter if it's quadratic or otherwise, if it has an inverse, we should be able to write this in what is called natural recursive form. I hope you enjoyed that little display. I'm going to do one more video to show you some real funky ones and how they work out in just a minute.